This is the second part of our 3-4 notes videos. So notice in this group of 4 equations, each of the equations starts in exponential form. And as we said in the last video, because exponentials and logarithms are inverses, if we start with a variable inside of a logarithm, we need an exponential to get rid of that logarithm. Here, if we start with a variable inside of an exponential, we need a logarithm to get rid of that exponential. They are inverses. They undo each other. That is the purpose of logarithms. So as we look at this equation, we have just one exponential, and that's true in each of the first two, and then in the second one we have an exponential on each side. When you have just one exponential, I want to rewrite this as a logarithm. So I just rewrite it using the basic definition. Log base 3 of 14 equals x. And I'm done. I could use the change of base formula to plug into my calculator log base 3 of 14 and figure out what that is. If we don't remember, the change of base formula says that log base 3 of 14 is the same as log of any base I want, 14, over log of that same base of 3. Now typically I'm going to choose either 10 for my base here or E, because those are the buttons on the home screen of my calculator. But that's how we would evaluate this. But I would say don't evaluate it, just leave it as is. No need to go any further. Number 6 starts the same. I've just got the one exponential on one side, so I just need to rewrite this as a logarithm. Log base 2 of 1.5 is equal to negative x, and then divide by negative 1, negative log base 2 of 1.5 equals x. And once again, I could stop there. Or if I wanted to use one of my properties of logarithms here to bring this negative inside, I could say x equals log base 2 of 1.5 to the negative 1, or 1 over 1.5. Either one is fine. Now once we look at number 7 and 8, immediately hopefully it jumps out at us that, okay, now I have a logarithm on, or sorry, I have an exponential on each side of the equal sign, and so I'm going to need to do a little bit more work here to get rid of that. There's two options. We have two problems here, so I'm going to show you one of each. The first option, which I think is a great option, is to sort of just ignore one of the exponentials for a second. Just pretend it's not there. So I'm going to say, all right, let's pretend that this is not there. Okay, if that wasn't there, well, now I only have one exponent, or one exponential. So I'm just going to rewrite this thing as a logarithm. Log base 2 log base 2 of 5 equals x plus 1. And then I would just subtract the 1 and it's all good. But unfortunately, this is here. So when I rewrite this, I need the 1 minus 2x to be here. And that's okay. I can still rewrite it even though that's there. I can still choose. Now, how did I know to choose to use log base 2 for my logarithm? Couldn't I have just as easily done log base 5? Yeah, either way, doesn't matter. If I did log base 5, then I would have ignored this exponent for a minute and then rewrote. Now that this is inside the logarithm, this exponent can be rewritten out front sort of as a coefficient. So let's do that. 1 minus 2x log base 2 of 5 equals x plus 1. Now I've got some fun algebra to do. I need to combine my x's, but this x is stuck inside these parentheses. So I have two options. I can either divide this log base 2 of 5 to the other side, or I can distribute it in. Either way, it's going to break me out of these parentheses here. I'm going to distribute it in. I think that's a much easier route. So first times 1. I'm going to write this a little different. I'm going to say it's 2 times log base 2 of 5 times x equals x plus 1. Now I just need to get everything with an x on one side of the equal sign, everything without an x on the other. I'm going to move my x's to the right hand side so that way they'll sort of all be positive. So this is log base 2 of 5 minus 1 equals x plus, and I'm going to rewrite this as log base 2 of 25, using that property of logarithms to bring this 2 as an exponent on the 5. And then, of course, there's an x. Now, I have two options. I could plug this into my calculator and just kind of combine the decimals, or I can just factor out an x. I prefer factoring out because then it keeps my answer exact. Log base 2 of 5 minus 1 equals x times 1 plus log base 2 of 25. And then I just need to divide by that expression there. So I'm going to have log base 2 of 5 minus 1 over 1 plus log base 2 of 25 equals x. So again, what we did here is we recognized I've got an exponential on each side and the base is different. So I basically just ignored one exponential, rewrote the remaining piece as a logarithm, and then said, oh wait, but that exponent was actually there. Used the property of logarithms to put it out front. Same setup over here. We've got two different exponentials, different bases on my exponentials on the left and the right hand side of the equal sign. So I could rewrite this as log base 4/3 of something, or as log base 5 of something, doing the same thing over here. The other option is sort of a more algebraic approach, where we're just going to say, okay, I know that logs cancel out exponentials, so I'm going to need a log here, and I'm just going to do the same thing to both sides. I'm going to pick a base, any base I want. Doesn't have to be 4/3 or 5. In fact, I would encourage it not to be. And we're going to say, okay, let's put that logarithm on both sides. Just like I could take the square root of both sides of an equation, or take the sine or the cosine of both sides of an equation. I'm going to do ln of each side there. So now this whole thing is inside of a logarithm, meaning the exponent can be brought down in front as a coefficient. And so I will do that. One minus x times ln of 4/3 equals x times ln of 5. I'm going to again have to distribute this out. So I've got ln of 4/3 minus ln of 4/3 x equals x ln 5. Add this to the other side, factor out an x, and divide. Ln of 4/3 is equal to x ln 5 plus x ln 4/3. And if I factor out and then divide, I'm going to get ln of 4/3 over ln, or natural log of 5, plus ln of 4/3 equals x. These certainly do not cancel out. There's a plus in the middle, so that doesn't cancel out. All right, that is our second part. We've got a few more to look at before we're done here.